the door?
I'm fine. It's hard enough to hear that. That is.
Okay, so today's the 27th, right?
I would say so, yeah.
Okay, so we continue with 2.6. The title for 2.6, what I like to name it, is Algebra of Functions. And, oops, function composition. Everything in this section is a review from a previous course. However, I will explain everything. Okay, when we talk about algebra, all we have in mind is addition, subtraction, multiplication, and division, right? But this time is with functions. So assuming we are given f and g, there are two functions. What if I'm asked to find f plus g, that's the name, of x? What if I'm asked to find f minus g of x? What about fg of x? And there is one more, f over g of x.
What about g over f of x?
Very good. I can't get away with anything in this class. I love it. Very good. So is this self-explanatory? Is this clear? Is this self-explanatory? So what will this mean?
F of x plus g of x.
Do we all agree with this? That's the definition. F plus g of x, it's nothing else but f of x plus g of x. What if I have now 3 in here? Let's say I have 3. What will that equal to?
Substitute.
Right. So it will be
f of 3 plus g of 3.
correct. Okay. What do you think about the second one? Self-explanatory. What will the second one mean? What do you think? That's it. What will the next one mean? Again, self-explanatory. Very good. And now these two, obviously, what do they mean?
Division.
Right, so f of x over g of x, I have to put a comma, and the word if. If what?
If g
How come that I-
equals 0.
Thank you. Perfect. What about the second one? The last one, I'm sorry. I meant to say the second division.
The inverse, if f of x doesn't equal 0.
Very good. If f of x does not equal 0. Is this clear? Okay, these are just names. And indirectly, they tell us what to do. Good. Now, here's a scenario. So let's say I have a function that is defined between 1 and 5. So here's the function. And I'm going to call it f. And let's say I have another function that is defined between 7 and 10, and this is it. And this is my function g. And now I'm going to ask you find f minus g of 2. Without looking at the graphs, what will you say?
F of 2 minus g of 2.
Now let's look at the graphs and draw a conclusion, or more than one. Is there any problem? Do we encounter any situation here?
G not equal to 0.
Right. So g undefined at x equals 2. So then what do I conclude about the difference of these two functions at 2? Can it be created?
No.
No,
Fine.
it doesn't mean anything. Okay, now in general, what do you think the sum, difference, product, and ratio will be defined on for these two specific functions, the gray one and the orange one?
X.
Right, but which x?
The x-axis.
For which particular x? Just name one for which the sum, difference, product, let's say, will
0.
exist. Let's take a look.
Oh, no, it can't be 0.
It can be 0. So for what will I be able to define these functions, sum, difference, product?
Well, there's no x value which each
Correct.
have.
Why?
Well, they never overlap.
Exactly. So that's the conclusion. If there exists no common domain, we cannot create anything, no function with these two functions. So the concept of common domain. With these two functions, I cannot create anything because there is no common domain. Function f is defined on 1, 5. Function g is defined on 7, 10. Nothing in common. There is no point in trying to create any function because there is no x value for which they both exist at the same time. So if I want to create a sum or difference, product, ratio, I have to pick two functions that have a common domain. So let's take a look. I'm on page 310. And let's say problem 10. I have f of x on 310. F of x equals 1 over x plus 8 plus 3 over x minus 10.
Right.
Can anyone tell us how was this function created?
Y equals 1 over x.
What are these two?
That.
Two other functions. What did we do to these two functions to get this function, right? So this is function 1 plus function 2. The question here is asking us to find the domain. What is the domain of function f? Not this one and not this one, but the domain of function f. Let's look at these two functions and identify what needs to be done. Look at the first one and say, oh, I know. This has to happen. And then look at the second one and say, I know. The other thing has to happen. And I'm going to write them down. For this one, what has to happen? What type is it? What type of function is it?
Rational.
Perfect. What could be the problem with a rational function?
Denominator equals 0.
Right. So then for this function, what do I have to write then? Awesome.
X cannot equal 8, negative 8.
Correct. So for this function to exist, I must write this. Do we agree? Perfect. So now it exists. In other words, for anything but negative 8. Now, can you repeat the same scenario for this one? What can you say?
X cannot equal 10.
Perfect. So now remember, we are looking for the common domain. For this to exist, I have to choose domain such that both exist at the same time. Okay, so let's find the common domain. What will that be?
Negative negative 8 and 10 to
In plain English, anything but negative 8 and 10. And that's guaranteed that both functions exist at the same time. Is that clear? Okay, awesome. Thank you. 28. One more. On the same page, 310. G of x, the square root of x minus 3, everything divided by x minus 6. How was this function created? Again, the same question, the domain of G. That's what we are asked to find. How was this function created?
Dividing one by the other.
Exactly. So dividing this function by this function. Perfect. So let's go back to the first function, the top. What can go wrong with the top? Forget about the bottom for a moment, as if it's not even there. What could go wrong with the top? Say it again. No?
It could equal the root of a negative number.
Correct. So for the square root to exist, what do I have to write?
X has to be greater than 3.
Right, I have to write x minus 3 greater than or equal to 0. I have to write the raw inequality for everyone to see. Perfect. So remember, the square root requires a positive or 0 underneath. If the square root were in the denominator, then I would have had to exclude the 0. But it's at the top. Good. So now I'm moving on. Looking at the bottom now. What could the problem be with the bottom?
It equals 0.
Right. So then x minus 6 cannot equal 0. These are the two conditions of existence of G. One, I have to make sure that the top exists. And secondly, I have to make sure that the bottom is never 0. Agreed? Good. So I solved the first one. And here I get x greater than or equal to 3. I solved the second one, x not equal 6. It is easier to look on the real line, put greater than or equal to 3 in there. I don't care for units. I just need to see what's happening. This is this. But now I have to remove 6. This is 6. I'll say not 6. And now I'm ready to write the domain of function G.
How do you say? Actually, bracket 3.
Bracket 3, I agree.
Comma 6 parentheses.
Comma 6 parentheses.
Union. Parentheses 6. Infinity.
Very good.
Again, in plain English, everything from 3 to infinity, but not 6.
Exactly. Absolutely. Good. Is this okay? Yes, sir. Is this okay? Now I would like to look at find two functions, pick two functions, and determine the sum, difference, product, and ratio. Before we do that, I want to make a comment or put in here a note. Note, the common domain will always be the domain of three different functions: the sum, the difference, and the product. So when I'm asked to find the sum, difference, product, and domain, and the ratio, and so on and so forth, this is how I start. I find the domain of function f, I'm going to show you in a minute. I find the domain of function g. I find the common domain, which will always be the domain of these three functions, and then I proceed. So let's pick two functions. On page 310, I'm looking at problems 31 through 50. Let's say 38. And we have f of x, 5 minus x squared, g of x, x squared plus 4x minus 12. And we are asked to find the following functions: f plus g, f minus g, fg, and f over g only. And of course, their domain. So one more time, the question here is, they're giving us two functions, f and g. They want us to create these four different functions that will have applications in something. We're not specified in this problem what they're used for. And all their domain. What do I know immediately about the domain of these three, so I don't have to write it 3 times? I'm going to write it only once. What do I know?
They have to have some in common.
Yeah, it will be the domain, which is the common domain. Perfect. Can anyone give us the domain of F? Think in terms of the graph if you want. We know how to graph that using transformations. This we'll review in chapter 3 again, how to graph that. So
I'm going to say all real numbers.
do you all agree? All your numbers, why? These are polynomial functions. That's another note for you. Polynomial functions are defined on negative infinity to infinity. So then you are telling me that the domain of F is negative infinity to infinity. Perfect. What is the domain of G? One more time.
Again, all real numbers.
Yes, because it's another polynomial function and it must be all real numbers. Perfect. Can anyone give us the common domain? So indeed, G, negative infinity to infinity. Common domain, which is also the domain of the sum, the domain of the difference, and the domain of the product. I have not said one word about the ratio. What is it?
All real numbers.
Right, because if F and G have the same domain, obviously the common domain must be all real numbers. So I don't have to identify these three again. Good. So now I'm ready to determine the sum difference product, and when I get to the ratio, all bets are off. Okay, I have to be very careful there. Ready? So F plus G of X. There is a lot of writing in this section. Sorry about that. I have to write the definition. What is the definition, please?
F of X plus G of X.
Very good. I have to write it at all times. Now I copy F, which is 5 minus x squared, plus, and I copy x squared plus 4x minus 12. I combine like terms. It happens that these two go away. So I have 4x minus 7. This is the function that represents the sum of the given functions. Okay, I will repeat for the difference. Can anyone dictate what this function means? Of course. Very good. Self-explanatory. I copy 5 minus x squared, but now I have to be very careful. I put minus and then parentheses. X squared plus 4x minus 12. So 5 minus x squared, I distribute negative x squared minus 4x and plus 12. Any questions? Any questions? In descending order, I start here, right? Negative 2x squared minus 4x and plus 17. What does this function represent?
That's F minus G of X.
F minus G of X. Good. The next step. Let's find the product. So FG, by definition, this means I have to write the definition so I don't make a mistake.
X times G of X.
Times G of X. I replace 5 minus x squared, and I multiply it by x squared plus 4x minus 12. I have to distribute. I distribute 5 to 3 terms and then negative x squared to 3 terms.
It's always fun distributing a binomial into a trinomial.
Are you with me? Is everyone okay so far? Yes? Is it a yes? Okay. So then 5 distributed to these two. 5x squared plus 20x and minus 60. Minus x to the 4th, minus 4x to the 3rd, and plus 12x squared. Yes, I have to rearrange it in descending order. What is the degree of this polynomial and where do I start? Yes, indeed. I start with x to the fourth. There is no other x to the third, so minus 4x to the third. So these are done. But now I have 12 and 5.
17x squared.
Very good. And these are done. And then 20x minus 60. What does this represent?
Fg of x.
Fg?
Fg of x.
Fg of x. Good. So now finally we reached f over g of x. I have to write a definition. What is the definition for this?
F of x over g of x.
Indeed. I copy 5 minus x squared and divide by x squared plus 4x minus 12. And as you see, I already put the equal symbol. Where am I getting at? What am I trying to do next?
It equals 0.
Well, of course, I have to find the domain. So it would be wise to do what?
I guess the x squareds cancel out, making the top 5 minus 1.
Okay, this is that example of brilliance
Leaving
in which you forgot that we cannot simplify terms.
Right.
So
Okay.
if I cannot simplify terms and I'm not allowed to, what am I getting at? So why did I put the equal symbol already and I'm expecting you to come up with another step? And what will that step be and why? Remember, we already identified the domain of these three functions. Here they are. The functions are here. Their domain is this, the common domain. So now I have to find the domain of this function. I have it, but I can't simplify it. But I have to
But you
do
still
so.
have the domain.
Yes, I still have to find a domain. So what should I do?
Factor it.
Perfect. What? Which of the two quantities?
Bottom.
Of course. When it comes to the domain, I'm not interested in what happens to the top. Doesn't mean anything. Awesome. Thank you, Brandon. I appreciate it. Negative x squared plus 5 because I wanted to put it in descending order. And I'm hoping there is nothing else I can do, right?
X minus 6, x plus 2.
Careful, one more time.
X plus 6, x minus 2.
Very good. Now I can identify the domain of the ratio. We just did something similar a few minutes ago with those two functions added together. It's the same thing, it's just that they are multiplied. So let's start by simply identifying what x cannot be.
Negative 6 and 2.
Very good. X cannot be negative 6 and it cannot be 2. Do we all agree with that? Therefore, can anyone give us the domain now?
Negative infinity. Negative 6. Union. 2. Then union to infinity.
Because if I skip the negative 6, 2, I skip infinitely many solutions. Or not solutions, part of the domain.
Yeah.
Very good. Any questions here? Okay, so these are 4 different methods, 4 different ways of determining new functions, correct? We're going to add the last one now, the 5th one. Function composition. This is totally different. It's not the sum, the difference, product, or ratio. Nothing of that kind. Okay. So here's the notation. F comp G or G comp F. I can continue forever. Or F comp F. Or F comp F comp G comp F. And I can, as I said, continue forever. What does this mean? So first of all, yes, indeed. Yes. So F comp G. This is the way we read it. The second one, G comp F. And then F comp F. Now, what does this really mean? Like always, Tom is already ahead of us. And F comp G of X is indeed F applied to G of X. Let's identify two things here. This,
You substitute one function for the other's x.
yes, awesome. This is the inner function. What do you think this one is?
Outer.
Of course. How did I pick the inner and the outer? Well, G is the closest to X. I apply G first. And then when I'm done applying G, then I will apply F. Let me show this with bubbles. I like the bubbles. So just as for, I'm talking about F comp G. This is the function we are looking at right now. Let's say this is X. What did we say we apply to X first?
G.
Yes. So if this is 5, and I apply function G, whatever the function is, it doesn't matter. Let's, exactly. Thank you. In this case, is G of X. So if this is 5, G of 5 would be another number, like 10. And what do I do to this number now?
Apply F.
I apply F.
F of G of 5.
F of G of X. Very good. This is the function composition. That's how it works.
Would be funny if we, well, no,
It depends on the function. I have to plug it in. So now here's a question. Is there, before I ask that question, I want to ask you, what is this set? What is this? This set for G. Name. It has a name. The set of X values for G. How do we call it?
G of X.
No, the set of X values for G. How do we call that?
The domain.
Thank you. Domain of G. Perfect. Forget about this one for a moment. What is this bubble for G? Name. Say again. Yes, it's also domain of, that's why I covered it, so you don't say domain of F, but you are way ahead of me again, that's fine. For now, yes, I have to write it because he already said it, so Brian is right. This is the domain of F. But I don't want to get there yet. I want to identify this bubble for G. But you're correct, I need that too. That will have been my next question. What is this bubble for G? Name. Where I get the values of G or the values of Y for G. What will this bubble represent for G?
Domain of X. No, it can't be. The range.
Of course, thank you very much. So that must be the range. So this is also the range of G. So now I have a question for you. Do you think that creating the function composition will require common domain? When we determine the sum, difference, product, and ratio, without the common domain, we could not create any of those functions. Now look at these bubbles and say, yes, they have to have common domain, or absolutely not. The common domain is not a question here at all, period.
Well, judging by the fact that none of the bubbles overlap, I would have to say no.
Correct. What could be the problem, though, here?
Well, then you wouldn't be able to make a function out of it.
In which situation I will not be able to create a function that is the function composition?
Not having any common domain.
No. We already know the common domain is not an issue. Forget about common domain.
Not
There is
having any
no.
overlap?
Here it is. Here it is. Right here. If the range of G and the domain of F don't work well together, but not common domain, one more time, the range of G and the domain of f. If this set, if G brings 0 here, for example, and f cannot be applied to 0, I can create the function composition. I will not test you on finding the domain of the function composition. This is part of 151, which is accelerated pre-calculus. I'm not going to ask you to do this. However, I just want you to remember that when we talk about the function composition, the issue of common domain is not an issue. But what could be the problem is that the range of G and the domain of f may not work well together. If I bring here a number that I cannot apply f to, we can never get here. So G of 0 is 5, but f cannot be applied to 5, so we cannot get here. That could be the only problem. Good. So let's look at two functions. What if we can go back to the same problems of the two functions we had. So you will not be asked to find the domain of function composition. So let's take a look. Let's say problem 58 on 310. And we have f of x, which is x squared plus 1, and g of x, which is x squared minus 3. We are asked several things. F comp g of x. We are asked g comp f of x. We are asked f comp g of 2 and g comp f of 2. Ready? So let's start with f comp g of 2. Oh, I'm sorry, I meant x. Definition. What is a definition? I have to write it first. Awesome, thank you. That's the outer. Leave it alone. You don't have to cross out anything. I'm just making a point. This must be replaced by, please dictate.
X squared minus 3.
Do you all agree with x squared minus 3? Thank you. Good. Now I take a moment. I deep breathe. I take a deep breath and I look at f. F says f of whatever equals whatever squared plus 1. Please dictate. F of whatever is whatever squared plus 1. I'm ready.
F of x squared minus 3 squared? The whole
Plus
thing?
1.
So say it again.
X squared minus 3 plus 1.
X squared minus 3
Squared.
squared.
Plus 1.
So f of whatever is whatever squared plus 1. And then
Plus 1.
plus 1. Okay, we have to expand that and we have a contract. It's already old. It's 5 weeks old. Ready.
X squared.
Very good.
9. No, plus 9. Right?
6 minus 6.
Oh,
Plus 9.
Okay, please remember the contract. It appears and it pops up everywhere. That's why I started with that. Not because I want to torture you. This is it. Now, since I have this function, which is f comp g, I go down the list of requirements and I see f comp g of 2. Why not? I'm done with that. Why not do that?
Simply plug into
Exactly. That's all I needed you to say. So, tell me how to plug it in and then we'll calculate.
You plug in 2 for x.
Very good. 2 to the 4th minus 6 times 2 squared plus 10. Which is the first operation I have to perform?
the 4th.
Yes, 16. Then 6 multiplied by?
4.
Very good. Plus 10. Then I add these two and I get 26. And I multiply these two, I get negative 24. 26 minus 24 is?
2.
Very good. So I'm done with these two. Now I want to create G comp f of x. G comp f of x. I have to write the definition first so I don't make a mistake. What do I write? Very good. Very good. Awesome. I look inside. You don't have to cross out anything. Again, I'm making a point. This is G of. Very good. At this point, I look at G. G says G of blah is blah squared minus 3.
X squared plus 1 squared minus 3.
We have a contract, so please dictate.
X to the 4th.
Thank you.
1.
Gun X squared
Very good.
minus 9.
Plus 1 minus 3, I'm going to write it directly minus 2. Very good. Very good. Any questions? Any questions? Good. Final question here was find G comp f of 2. So I have the function. So I'll go ahead and find it. So G comp f of 2 is 2 to the 4th plus 2 times 2 squared minus 2. Please give me the answer.